How's everyone doing today? Anyone tired from the conference yet? I know I am. It's only been 2 days. All right, so what is DIMO? And maybe I'll just start with an introduction of myself. So my name is Yevgeny. I spent a decade working in automotive IoT with Ford, GM, Chrysler, most of the brands you know of. And what I learned in that time is the data being owned by the car company does not create a developer ecosystem. And during that time, I've also learned that it's very important for us to solve the problem of digital infrastructure. So today I'm going to cover how we think about proof of data DIMO, what mobility challenges I want us to solve, how we expect DIMO to be leveraged, and I'll give a few demos of how we validate that the vehicle data is real. So this might be a silly question, but when you're building an open protocol for vehicles, people can create fake ones. This is not a problem that car companies deal with, but it's one that we've created. And the second part is it actually moving, right? Whenever you create an incentive, you have people who definitely want to game the system, and that's something we've had to solve for. And it really comes down to, why are we doing this and what are the challenges we want to solve? So in the 10 years and, multiple APIs that I've built, what's that? Yeah. I was going to just take it, walk around. Can I? Okay. All right. Okay. So, there's 140 car brands in the world, and they don't really like to work together. They used to on making standards for the cars, but they haven't done this in any digital format in the last 30 or 40 years. Very recently, we've been talking about our physical infrastructure in the United States, and while that's first part of it, what's also happening during the time is we're creating new digital infrastructure. And the way it's heading now, Google's going to end up being the company that provides the stoplight API and the connectivity API to the parking garage and all of these things. And that's not a world I want to live in. And it comes down to privacy. So all the data that, when you buy a car, that data should really be yours. That's our true belief, right? It's the second most expensive thing people buy after their house in their life. All of the existing solutions that we have today do not focus on privacy, and most of the OEM solutions don't even have basic roles and rights to say you can see this, not that. So with what we're building, what we're hoping people will build on this network is infrastructure for charging. One of the things that has been happening recently, we've had a lot of charging infrastructure companies come to us and they say, we're trying to put charging in all across the country, whether it's US, Europe, or anywhere we're alive. They don't know where to put it. The city doesn't know that, and the company making the car doesn't give it to them. So one of the core use cases, if you buy an EV, you have to deal with the charging, right? And one of the things you can build on our network is charging solutions. You can very easily find a charger. You can find a compatible charger. And next part is payments, right? I have several friends that still work in the auto space, and as of right now, every car coming out in 2030 will have a Diebold machine inside for your payments from inside the car. So whether you're paying for parking or gas, Diebold and Visa will be the norm, which is another world I don't want to live in. We have this other thing called machine-to-machine payments using a blockchain that works a little better and lower fees, right? Another thing, with cars, they collect a lot of data, and it can be misused, but it can also be used for public goods. A car driving around knows the weather, and in places where there are no weather stations, that's something me and Manos have been actually discussing, right? The average city in the United States spends $60,000 to $70,000 to hire a contractor to drive around and tell them where the potholes are. When we're all here driving around, we probably drove here, right? This data could be made available for cities, right? For governments, for anyone that wants to use it. This is one that's, data monetization is interesting, right? So any car made in the last 10 years, your data is already being sold now and now and now. And some people will say, I don't want any data to be sold, I just want to be the owner of it. And I think that's fine. I think that's a use case that should be served. If you own the asset, you should be able to completely say, only mine. That being said, I think, we're mostly capitalists. Most people would agree to data sales as long as they're able to say, I will sell this and not that, and they have something to earn, some value to get out of it, right? And I've also spent some time in self-driving car space, and this is where like the future vision for DIMO comes into play. From launching Ford's self-driving fleet in Miami and Austin, what ends up happening is you have a very interesting problem. One car, which is a robot on wheels, the first robot on wheels out in the physical world, that needs to talk to a car from another brand. And how they're going to do that is not very clear at the moment, because the first thought is, well, Ford will just integrate to all the other car companies. And then all the other car companies will integrate to all the other car companies. And while Accenture might be very happy with that, in reality, that's just not functional, right? There needs to be a common standard for this mobility, smart city future with optimized transportation to work. It can't just be left up to a centralized API. So now I'll get into a little bit of how we validate the data and parts of our protocol and how we're thinking about validating it, how a developer on the other side is going to validate it, and how we make sure all this data is real. So the very first thing is, we've spent a lot of time building out how a manufacturer can make a DIMO compatible device. It's not something that can be made completely trustless as much as I would like to. Hardware needs support, right? We want the manufacturer to support that device long term. We want to make sure they're using high quality chips. These devices aren't dying. But once you're an approved manufacturer, you can deploy your own contract to make devices. So every single time a device is getting tested at the end of the assembly line, it's actually getting minted at that time in a contract. And we capture the serial number and the address of the device. And this is the first layer of validation for any data received within the network, is checking the signature on that data using the secure element in the device. The second thing is going to be very, very vehicle specific, and I don't expect most people will know this natively, but every vehicle made in the last 30 years uses a protocol called the CAN bus. It's most similar to Ethernet if everything was only UDP broadcasts. It uses only 2 wires and 11 bits. The first 3 bits is the header, and the last 8 bits is the data. So here is an example of what that looks like. And the average car today has over 100 to 200 modules inside it. And they're constantly talking to each other to try and, I wouldn't say consensus, but they're certainly reacting to each other, right? You press on the gas pedal, the engine RPM increases, the transmission sees that, it shifts down in gear. Then once again, depending on how the pedal movement or gearbox or anything else, they talk to each other to come to an agreement on what they should all be doing. So what our device does, and I have one here, this is the Macron. We launched this just 2 months ago and sold about 8,000 units. And then we also have another device called the AutoPi. We've sold about, I think, 10 or 12,000 units of that one. But this device talks to the car's message bus. It talks to as many modules as it can to try and generate a proof of what this vehicle is and to timestamp this individual vehicle. Serial numbers, versions of the firmware, right, the VIN of the vehicle. Once that data is collected and signed by the secure element, it's used to generate a verifiable credential, right? Just an example of what that looks like here, but this is what we use to do rewards validation, as well as what another developer would be able to take a look at to see if this is real. You can check the signature back to a device that was created. You have the entire history of when the vehicle was created. All of these things combined together create a vehicle ID. The second part of this is, okay, I get that you guys are talking to a car module, but what if it's plugged into a wall? And that's where the more fun part about movement comes in. So today, we don't have the density to do, vehicle-to-vehicle validation, but we can use existing infrastructure to validate. Example, with the AutoPi, we use a cell network, and as part of that, we know which cell tower the data packet came through. You can use this to check against the location from the device that it's sending to see if they're remotely in the same location. And if you're actually driving, you'll probably be talking to more than one tower during a given week. Same thing for the Macron, which uses the Helium network, the people's network. Helium network, when we receive the data, tells us which path it took and which hotspots heard it. So once again, we're building trust based on another deep-in project that's providing LoRa coverage. Here's an example of what that actually looks like when the data is received. So you can see the source, it's a 0x address of the actual device. You can also see the subject, which is the vehicle that is submitting on behalf of, the payload, the signature, and also, to highlight, the path that it took. In this case, it was a helium hotspot, short wintergreen whale. I don't know if that belongs to anyone here, but this is what we use to validate, right? And you have to talk to a minimum number of hotspots to be able to be called a valid vehicle within the network. So what future improvements, right? So today we have what I would call, first step is permissions. Actually, Vitalik tweeted about that, can we get some fancy ZK or maybe just at least data permissioning, please? So the first step is we've added data permissioning to your vehicle data. So you can very precisely say, just my odometer, just my VIN, and depending on the application, you can very specifically say what to share. But in the future, we want to make this even more privacy preserving. I personally speed a lot, so I would like some ZK, please, right? To where I don't have to share more than how many miles I'm driving in a range and maybe which region I'm in. So that's one area that we've started looking into recently. The other thing is, as the network grows and as we have more cars on the road, we really can move away from even hotspot validation or cell tower validation and just having the cars validate each other. And that's what I think is going to be the next stage for DIMO. We can start doing this in New York in the near term. But in the future, as we get more and more deep in infrastructure, now I'm hearing about charging networks. All of these pieces built in a verifiable way means you're creating a digital history, right? That you charged here, your vehicle was seen here. All of these things together create something that's very hard to fake, because you would have to fake helium, you would have to fake the charging network, and 50 other cars. And that's what really makes it, let's say, bulletproof in the long term, is being able to validate between all of these devices, which I think of as future robots using AI, right, to help us be more efficient as humanity.